Let's find the area of the region bounded by the graphs of x plus y equals 4, y equals x, and y plus 3x equals to 4. We're going to sketch this region carefully first by finding where the lines intersect. So let's look at the intersection of the first two lines. We're going to replace y with x in the first line, so x plus x becomes 4. 2x equals to 4, and that means x equals 2. Plugging back into the second line or the first line, 2 for x, y also equals to 2. So we have a point of intersection that is 2, 2. The second line and the third line, we do the same thing. We replace in the third line y with x, so x plus 3x becomes 4. 4x becomes 4, x equals 1. Plugging that back into the second or third line, we also find that y equals 1, and the point of intersection is 1, 1. For the first and the third line, we solve for y. The first line gives us y equals 4 minus x. The second line gives us y equals to 4 minus 3x. Setting these equal, 4 minus x equal to 4 minus 3x. We cancel the 4's, multiply by minus 1, so we get x equal to 3x. That can only mean that x is 0, and plugging it for x equals 0 into the first line or into the third line, we find y equals 4. So the point of intersection is 0, 4. Let's graph this region now. We're going to have this grid, the x-axis and the y-axis. And we just need to go up to 4 on the y-axis, 1, 2, 3, 4, and all we need is to go up to 2 on the x-axis. Now the three critical points are 1, 1, 2, 2, and 0, 4. The line y equals x right here goes through 1, 1, and 2, 2, so this is the line y equals x. The line x plus y equals 4, so solving for y, this is the line y equal to 4 minus x. It passes through 0, 4 and 2, 2. And then the third line right here, this is the line that goes through points 0, 4 and 1, 1. That's the line y equals to 4 minus 3x. So to find this area using integration, we're going to divide it into two parts because we cannot express the area as one integral. It has to be two integrals. Let's call this the left portion of the area. Let's call this the right portion of the area. So for the left portion of the area, the integral will run from 0 to 1. The function on top is 4 minus x. The function on the bottom is 4 minus 3x. And we're going to integrate that. That would give us the left portion of the area. The right portion of the area is the integral from 1 to 2. And the function on top is 4 minus x. The function on the bottom is x. And all we have to do is integrate these two, add them, and we have the area. So let's do that. The first integral, 4's cancel, minus x minus a minus 3x gives us 2x. So the first integral is from 0 to 1 of 2x dx. And the second integral is from 1 to 2, 4 minus 2x dx. These are very easy integrals. The first one is just x squared evaluated from 0 to 1. The second integral is 4x minus x squared evaluated from 1 to 2. And we get 1 plus 8 minus 4 minus 4 minus 1. So this is equal to 1 plus 4 minus 3, which is equal to 2. The area of this region is 2 units squared. There's another way to evaluate this area, so let's go ahead and do that. I'm going to draw the grid one more time. And you should always practice this using both methods because sometimes the first method is better, sometimes the second. So here are the 2 points, 1, 1 and 2, 2. So this is 1, 1. and this is the point 2, 2. We also need the point 0, 4, which is right over here. Let's sketch our region once more. Here it is. And this time I'm going to solve for x as functions of y. This is x equals y. The function up here is x equals to 4 minus y. And remember, our third line was y plus 3x equals 4. So I'm going to solve for x. 3x equals to 4 minus y. X equals to 4/3 minus 1/3 y. So this is the line x equals to 4/3 minus 1/3 y. And this time we're going to look at our area, our region, as the top region and the bottom region. The area is equal to the bottom area of the bottom region, which is the integral from 1 to 2. The function on the right is y minus the function on the left, which is 4/3 minus 1/3 y dy, plus the area of the top region. That would be integral from 2 to 4. The function on the right is 4 minus y minus the function on the left, which is 4/3 minus 1/3 y. So let's simplify this and then integrate. The first integral, y minus a minus 1/3 y, is 4/3 y. So this is the integral from 1 to 2. 4/3 y minus 4/3 dy. And the second integral, 4 is 12/3 minus 4/3, so that's 8/3. So it's plus the integral from 2 to 4, 8/3. And we have minus y minus a minus 1/3 y, so that's minus 2/3 y dy. Okay, and let's integrate that. See that we also get 2. The integral of 4/3 y is 2/3 y squared minus 4/3 y, and that's evaluated from 1 to 2, plus integral of 8/3 is 8/3 y. The integral of 2/3 y is 1/3 y squared, and that's evaluated from 2 to 4. So let's carefully plug these in. 4 times 2, we get 8/3 minus 8/3. So that's 0. And plugging in 1, we get 2/3 minus 4/3. Plus, plugging in 4, we get 32/3 minus 16/3. And then plugging in 2, we get 16/3 minus 4/3. So let's do a little bit of algebra. So this is 0. Minus, or 2/3 minus 4/3 is negative 2/3, and the minus in front of that gives us positive 2/3. 32/3 minus 16/3 is 16/3. 16/3 minus 16/3 is 0. Minus a minus 4/3, we add up 4/3. So the answer is 6/3, and once again that's equal to 2, just like it was before. So we have 2 is the answer, integrating either with respect to x or with respect to y. There's another way to solve this problem, but this is just, it's not a practical way to do areas of regions, just only here because it's a triangular region. So let's revisit this one more time and see that we can get the same answer. Once again, the points are 1, 1, 2, 2, and 0, 4. This is my region right over here. That's 1, that's 2, 1, 2, 3, 4. This time we're just going to use geometry, and we're not going to use calculus at all. So look at this. This is the line y equals x, right? This is the line y equals to 4 minus x. The slope of this line right over here is 1, and the slope of this line equals -1. Remember, when slopes are negative reciprocals of one another, which these are, the lines are perpendicular, so this is a 90-degree angle, this is a right triangle. We're going to use the basic formula for the area of a right triangle. Here I'll draw one right over here. If I call this B and I call this H, the area is 1/2 base times height. So we're going to need to find this length. This is B and this is H. So B is just a distance from point 11 to point 22. Using the distance formula, B is equal to the square root of 2 minus 1 squared plus 2 minus 1 squared. So that's 1 plus 1 under the radical. B is equal to square root of 2. And then H is the distance from the point 22 to the point 0,4. So that's equal to the square root of 2 minus 0 squared, that's 4, plus 2 minus 4 squared, that's also 4. So this is equal to square root of 8. And our area then is equal to 1/2 base, which is square root of 2, times the height, which is square root of 8. And that's 1/2 square root of 16. Square root of 16 is 4. 4 divided by 2 is 2. So we're able to find the area of the region using 3 different methods. All 3 gave us the answer of 2. For more videos, go to www.mathprepvideos.com.